Pluto, a distant and enigmatic celestial body, was once part of our solar system's planetary family. However, recent alarming statements from prominent astrophysicists like Neil deGrasse Tyson and Michio Kaku have thrust Pluto back into public attention. They have made a startling revelation: Pluto might be on a potential collision course with Neptune. But how could such an event happen, and what would the consequences be? Is this a rare cosmic anomaly, or is there something more to this imminent cosmic impact? Join us as we explore the possibilities of a potential Pluto-Neptune collision. Pluto, once classified as a planet, but later redefined as a dwarf planet due to its peculiar orbit, continues to captivate the scientific community. According to recent research by leading scientists, Pluto's trajectory is dangerously close to Neptune's orbit. Renowned astrophysicists like Tyson and Kaku are raising alarms about the potential for a catastrophic collision between these two planets, a scenario that could pose a significant threat to Earth. Unlike any other planet in our solar system, Pluto's journey around the Sun is highly unusual. It takes a remarkable 248 years to complete just one orbit. Since its discovery in 1930, Pluto hasn't even finished one full orbit, which adds to its mystique. But Pluto's orbit is not just slow, it's also highly elliptical, vastly different from the more circular orbits of the larger planets. To complicate things further, Pluto's orbit is tilted at an angle of 17 degrees to the plane of the solar system. This inclination makes its path much more extreme than the other planets, adding layers of complexity to its movement. One of the most intriguing aspects of Pluto's orbit is its interaction with Neptune's orbit. For roughly 20 years of each orbit, Pluto comes closer to the Sun than Neptune does, defying what we might expect based on the relative positions of planets in our solar system. The answer lies in the gravitational influences of other celestial bodies, especially the large planets. The study of Pluto's orbit began shortly after its discovery. Early astronomers were puzzled by its strange path. Unlike other planets whose orbits are somewhat aligned with the ecliptic plane, Pluto's orbit stood out due to its steep tilt and elliptical nature. The realization that Pluto's orbit crosses Neptune's was a major point of scientific curiosity. Despite these irregularities, the stability of Pluto's orbit is a remarkable feature of space mechanics. The phenomenon known as the three-body problem comes into play when studying the movements of Pluto, Neptune, and the Sun. This problem involves understanding the way three celestial objects move and affect each other through gravitational forces. Predicting their paths is a complex task, and this is where terms like IML libration, scope libration, and VZK wobbling become relevant. The concept of IML libration refers to the fact that when Pluto crosses Neptune's orbit, it remains at least 90 degrees away from Neptune, ensuring their paths do not intersect. Scope libration describes the vertical movement of a celestial body in its orbit. For Pluto, this means that when it gets closest to Neptune or any other large planet, it is positioned above the plane of their orbits, offering extra protection from potential collisions. Another crucial factor is VZK wobbling, named after the researchers VZ and K, who studied how space objects interact through gravitational forces. This phenomenon explains how Pluto, Neptune, and the Sun's gravitational pulls influence each other, keeping Pluto's path stable despite its apparent erratic behavior. Even though Pluto's orbit may seem unpredictable, this wobbling mechanism helps maintain its steady motion over long time scales. These complex forces help ensure Pluto's orbit remains stable, preventing it from crashing into Neptune or deviating wildly. The three-body problem is essential for understanding how orbits change due to the gravitational influence of multiple objects. Studying this helps us gain a deeper understanding of Pluto, our solar system, and even distant celestial bodies and their stars. Mathematical simulations conducted in the late 1980s revealed that although Pluto's orbit has these stabilizing factors, it is still chaotic. Small changes in its starting conditions could lead to significant variations over millions of years. Despite this inherent chaos, Pluto's orbit remains stable over incredibly long time scales, effectively keeping any potential disruption in check. Recent computer models have provided new insights into how the gravitational influences of giant planets like Neptune, Jupiter, and Saturn affect Pluto's orbit. These models show that Pluto's relationship with Neptune is unique. For every 2 orbits that Pluto completes around the Sun, Neptune completes 3. This resonance helps to stabilize Pluto's orbit. But Neptune is not the only force at work. Jupiter's gravity plays a key role, as does Saturn's, providing additional stability. These simulations demonstrate that Jupiter's gravitational pull alone is strong enough to ensure Pluto remains in a stable orbit for billions of years. Together, Neptune, Jupiter, and Saturn work in tandem to keep Pluto safely on its course, avoiding any catastrophic collisions or other disruptions. These gravitational forces are essential for maintaining order in the solar system. Without them, the system would be much more chaotic, with planets and dwarf planets like Pluto potentially colliding or being ejected from their orbits. Understanding Pluto's orbit is crucial to gaining a clearer picture of our solar system's dynamic nature. Pluto's case serves as a prime example of how even the most seemingly unstable orbits can achieve stability through the intricate interplay of gravitational forces. It also underscores the importance of continuous observation and exploration to better understand our place in the universe. Peel back another layer of cosmic mystery. From its discovery in 1930 by Clyde Tombaugh to the groundbreaking New Horizons flyby in 2015, Pluto has remained a symbol of how our understanding of the universe is constantly evolving. What began as the ninth planet has transformed into a dwarf planet that challenges our very definitions of what a planet is, and now perhaps a harbinger of deeper questions about orbital chaos and long-term planetary dynamics. As we look to the future, ongoing missions and advanced simulations will continue to monitor the intricate dance between Pluto, Neptune, and the other celestial giants. Space agencies and observatories worldwide are investing in more precise telescopic measurements, deeper sky surveys, and higher-resolution simulations. These efforts aim not only to understand Pluto's path, but also to reveal how similar interactions might unfold in exoplanetary systems light years away. Moreover, Pluto's story speaks to the philosophical side of science, our attempt to find order in the seeming chaos of the cosmos. The idea that a distant world with such a wild and tilted orbit can maintain harmony with its massive neighbor Neptune offers both scientific insight and poetic wonder. It teaches us that stability in the universe is often a product of complexity, not simplicity. Whether Pluto and Neptune will ever collide remains uncertain. Current models suggest it is extraordinarily unlikely for at least the next few billion years due to their resonant orbital relationship. But the inherent unpredictability of chaotic systems means the possibility, however remote, cannot be entirely dismissed. Like so many celestial phenomena, it becomes less a question of if and more a matter of when and how. In the meantime, Pluto continues to inspire. Its icy plains, towering mountains, and vast nitrogen heart revealed by New Horizons tell us that even in the cold, dark outskirts of the solar system there is beauty, complexity, and motion. It reminds us that the boundaries of exploration are always moving, and with each observation we redefine what we thought we knew. As we continue to study the heavens, the tale of Pluto and Neptune remains an open chapter, an evolving narrative shaped by mathematics, physics, observation, and imagination. It encourages us to keep watching the skies, to refine our models, and to never stop questioning. Because out there beyond the orbit of Neptune, Pluto waits not just as a celestial body, but as a symbol of how much more we have yet to uncover in the story of the universe.